started with this. So we have this little introduction to the chapter, design patterns revisited, and then we're going to move on to the first one, which looks like it's going to be command. So, getting started. Design patterns. Elements of reusable object-oriented software is nearly 20 years old by my watch. And that's, of course, whenever this book was published, which I think was a while ago now. Unless you're looking over my shoulder, there's a good chance design patterns will be old enough to drink by the time you read this. Well, he actually answered that question, before I did. For an industry as quickly moving as software, that's practically ancient. The enduring popularity of the book says something about how timeless design is compared to many frameworks and methodologies. While I think design patterns is still relevant, we've learned a lot in the past couple of decades. In this section, we'll walk through a handful of the original patterns the Gang of Four documented. For each pattern, I hope to have something useful or interesting to say. I think some patterns are overused, singleton, while others are underappreciated, command. A couple are in here because I want to explore their relevance specifically to games, flyweight, and observer. Finally, sometimes I just think it's fun to see how patterns are enmeshed in the larger field of programming, prototype, and state. All right, and so the patterns we'll be going over: command, flyweight, observer, prototype, singleton, and state. So let's move on. Command. Command is one of my favorite patterns. Most large programs I write, games or otherwise, end up using it somewhere. When I've used it in the right place, it's neatly untangled some really gnarly code. For such a swell pattern, the Gang of Four has a predictably obtruse description. Encapsulate a request as an object, thereby letting users parameterize clients with different requests, queue or log requests, and support undoable operations. I think we can all agree that that's a terrible sentence. First of all, it mangles whatever metaphor it's trying to establish. Outside of the weird world of software where words can mean anything, a client is a person, someone you do business with. Last I checked, human beings can't be parameterized. Then, the rest of that sentence is just a list of stuff you could possibly use the pattern for. Not very illuminating unless your use case happens to be in that list. My pithy tagline for the command pattern is: a command is a reified method call. Of course, pithy often means impenetrably terse. So this may not be much of an improvement. Let me unpack that a bit. Reify. In this case, in case you've never heard of it, means make real. Another term for reifying is making something first class. Reify comes from the Latin res, for thing, with the English suffix "fy." So it basically means thingify, which honestly would be a more fun word to use. Yes, absolutely. Plus also, like, JavaScript functions are first class already. So this is something that, like, if you're used to, so I'm not super familiar with C++, but like PHP, for example, functions are not first class, but you can inject functions into essentially another function as a parameter if you wrap it inside of a class. And I guess in that case, that is reifying that function. Both terms mean taking some concept and turning it into a piece of data, an object that you can stick in a variable, pass to a function, etc. So by saying the command pattern is a reified method call, what I mean is that it's a method call wrapped in an object. So that's that entire, like, hey, we're going to put the method and put it inside of the class so that it's essentially wrapped around. Like, yeah, that's exactly what it sounds like we're going to be doing with this. That sounds a lot like a callback, first class function, function pointer, closure, or partially applied function, depending upon which language you're coming from. And indeed, those are all in the same ballpark. The Gang of Four later says, commands are an object-oriented replacement for callbacks. And then a sidebar, reflection systems in some languages let you work with the types in your program imperatively at runtime. You can get an object that represents the class of some other object, and you can play with that to see what the type can do. In other words, reflection is a reified type system. Anyways, back to the other slug line. Commands are an object-oriented replacement for callbacks. That would be a better slug line for the pattern than the one the Gang of Four chose. But all of this is abstract and nebulous. I like to start chapters with something concrete, and I blew that. To make up for it, from here on out, it's all examples where commands are a brilliant fit. All right, so here we're going to get into the real stuff. Configuring input. Somewhere in every game is a chunk of code that reads in raw user input, button presses, keyboard events, mouse clicks, whatever. It takes each input and translates it to a meaningful action in the game. So he uses jump, fire gun, lurch, and swap weapon. A dead simple implementation looks like, all right, so here we are with the first code. So I'm not going to just like read the code completely. Like, it's void input handler : handle input. That I don't think that's going to be any useful to anybody. But what I plan on doing is summarizing it. Obviously, this is C++, if you missed some of the earlier chapters that explain what kind of code this is going to be. So we have a function input handler. It doesn't return anything. It looks like we have a class input handler and a static function handle input on that. And then a bunch of just if-else statements to check like, hey, did we press the button? If so, run this function. This function typically gets called once per frame by the game loop, and I'm sure you can figure out what it does. This code works if we're willing to hardwire user inputs to game actions, but many games let the user configure how their buttons are mapped. To support that, we need to turn those direct calls to jump and fire gun into something that we can swap out. Swapping out sounds a lot like assigning a variable, so we need an object that we can use to represent a game action. Enter the command pattern. We define a base class that represents a triggerable game command. So basically he's creating a class command. Now he's using virtual. So I'm not familiar with virtual keyword. I don't know if that's like specifically a C++ thing, but okay, so public. So those are available in the instantiated object outside of it. Okay, so he's going to have tilde command. I don't know what tilde means for that either, but okay, so he's going to have a function command and then also a function execute assigned to 0. I think that this is an interface because the sidebar is when you have an interface with a single method that doesn't return anything, there's a good chance it's the command pattern. So execute is the single method that doesn't return anything. I don't know what the command in the command is, unless that's like the constructor. Then we create subclasses for each of the different game actions. All right, so class jump command. And then all that does is have a execute function inside of it that calls jump. and fire command that when that executes, the fire gun function. Okay, so basically we'll have 4 classes, one for each thing. So in our app that we're building, we only have one command. That's the jump command with the space bar. We're trying to make it so we can bind it to any key whatsoever. And so we're going to need the command class and then the jump command. In our input handler, we store a pointer to a command for each button. Okay, so we also need an input. Oh, so he had an input handler class already. So we didn't do that. We just threw ours in a main logic in the main game loop. So that's already one abstraction that we can make as well. So an input handler command that has a handle input function. And that handle input function is going to have functions to bind commands. So methods to bind the commands. I'm not sure exactly what to put in there at this point in time, but we'll figure it out. I do think it's interesting. He has, so private and then the command type. And so button X, button Y, button A, and button B. So it sounds like we're going to have so we're going to be able to pass in the jump command. And because that's a child of the command, because it extends it, we can now assign, that's what he means by binding. Okay, we're going to assign this jump command instantiation of a class to button X, let's say. Now the input handling just delegates to those. Okay, so void input handler. Okay, handle input. Okay, so that if pressed button X, we then say, hey, button X, execute. So it's still going to be if else ifs, but now it's going to be a little bit. We're no longer just specifically calling a function or specifically checking for, specifically calling one function. We're calling a button, which is dynamically assigned. Where each input used to directly call a function, now there's a layer of indirection. This is the command pattern in a nutshell. If you can see the merit of it already, consider the rest of this chapter a bonus. All right, and then there's a sidebar up here. Notice how we don't check for null here. This assumes each button will have some command wired up to it. If we want to support buttons that do nothing without having to explicitly check for null, we can define a command class whose execute method does nothing. Then, instead of setting a button handler to null, we point it to that object. This is a pattern called Null Object. So I guess that would be if somebody remaps button X, but then they're like, I don't really want anything, and then they just leave. And so they just delete the mapping. We could assign it basically null command. Directions for actors. The command classes we just defined work for the previous example, but they're pretty limited. The problem is they assume there are those top-level jump, fire gun, etc. functions that implicitly know how to find the player's avatar and make him dance like the puppet he is. That assumed coupling limits the usefulness of those commands. If the only thing the jump command can make jump is the player, let's loosen that restriction. Instead of calling functions that find the commanded object themselves, we'll pass in the object that we want to order around. Okay, so our execute is now going to take in basically the player. He calls them the actor. Here, game actor is our game object class that represents a character in the game world. We pass it in to execute so that the derived command can invoke methods on an actor of our choice, like so. You wonder if we can maybe port the C++ code to JS. Actually, that's a really good idea. Let's maybe come back here. Let's try this. So I have my editor up here. So I'm thinking, first of all, I want to change branches over to, what is this? Chapter 2 command. And I'm going to create a folder in here, which is, I don't know, like I'm going to call it the playground. And inside the playground, we're going to look at command.js. So I'm going to do this all in one file. That way we can sort of see how it's all interacting with each other. All right, so all right, so if we go back to the beginning of the code, so this is the initial sort of like starting place of what we have, which looks like this, which of course is not JavaScript whatsoever. So this is assuming that we have a class input handler, and then we have a static method called handle input on it. And I think, can I do static? I think I can. So static handle input like this, and this stuff is actually inside of it. All right, so if is pressed, so this also means that we have some kind of is pressed method in here. And we'd probably want that to be like the X button, so we can do is pressed, and this is, well, so this is interesting because if this is static, then we can't actually access to like this. So I don't necessarily think that it should be a static like function. Let's see, so if we have handle input, then we can now do this dot is pressed. Now these are constants that look like they're going to be available just game wide. So we have button X, button Y, button A, and button B. And then of course we have global functions as well. And so that's what this input handler is really looking like. So is pressed is going to take in a button, and we're just going to return if, so the code here is return Boolean, like a true if button is pressed, otherwise return false. If we look at our code, the way we did this, I think that was in game. We have this if key is down, key code space. And so we could essentially do the same thing here. So return key is down, and then it'd be the button. And then that's just a Boolean true or false if the key is down. So we would need to instantiate the input handler. So const input handler equals new input handler. There's no constructor on this, but now we could basically call handle input every single frame in our game command. And I wonder if like maybe we should like immediately start doing this in order to like then do the refactor, because to get to where we're essentially he is at the beginning of this with our game. Because we are going to need something similar to this, but let's go ahead and take a look further to see where we are. All right, so then we're going to have the command class. So if we take a look at that, class command. So he's going to have just a single method that doesn't return anything. Well, it's JavaScript, so we don't really care about typings in JavaScript. So this is really just execute like that. Now, creating an interface in JavaScript is interesting. If we're extending this, which we are in this very next example here, this is kind of an interface right now. It just defines what is on this command, and we can overwrite it in the children functions. But there's no like compilation of like, oh, you must do this. Not like traits in Rust. All right, so then if we now create subclasses, we only have one in ours. So that's going to be class, well, if we take a look at theirs, jump command extends command. And then he's going to now implement this execute command and then call jump. And that's all it really is doing. So that's where this like wrapping and reifying is happening in like real life. So we're going to have execute. So we're overriding here. And all we're doing here is just saying jump. In our input handler, we store a pointer to the command for each button. Okay, so class input handler, handle input, methods to bind commands. And then we have, okay, so private, they have the command, button X, button Y, button A, button B. I wonder if we need to like pass that in at in the constructor here, because how else are we going to get into it unless I'm somehow like creating a new at this point in time? I think we need a constructor here, and so this is going to be our like it's the jump command. So jump command, this dot jump command equals jump command. So now we're storing that inside of our input handler. Now, the input handling delegates to those. So if button is pressed, if, okay, so handle input. If this, is pressed button X, so we need now to, like, this is where we need to bind button X to the jump command, but like know that it's specifically the jump command, don't we? So how do we know that? I wonder if that's going to be a completely rebinding function or something we have. I kind of want to like try to implement this. Ooh, I wonder if we have a rebind function. So if we have like a rebind. So if this is pressed button X, jump. Button X is global still, so we don't want that. We specifically need like this space bar to find if the space bar and then call, because we're replacing this. This dot jump command dot execute, something like that. Oh, it's button X execute. Oh, okay. Now, is that because we do a new command for button X? So like button X is a new command. And then we have to, so I guess it's that binding. It's the binding that we need to figure out. So this is wrong because this is still mapped in. We still don't have the ability to bind. So let's continue on. Directions for actors. The command classes we just defined work for the previous example, but they're pretty limited. The problem is they assume there are these top-level jump, fire gun, etc. functions that implicitly know how to find the player's avatar and make him dance like the puppet he is. Wait, did I do this one already? No, I don't think I... That sentence sounded like exactly the same as one I've already read. That assumed coupling limits the usefulness of those commands. Oh wait, no, we did do this. Right, because now we're going to pass in the actor, and so then we just tell whatever is passed in to be okay, execute that one. Okay, so now we can use this one class, the input handler class, to make any character in a game hop around. We're just missing a piece between the input handler and the command that takes the command and invokes it right on the right object. First, we change handle input so that it returns commands. So if is press button X, return button X. Interesting. So at the end, it returns null, which does mean we're going to have to check for null. I thought that was the entire point, so we don't have to check for null. It can't execute the command immediately since it doesn't know what actor to pass in. Here's where we take advantage of the fact that the command is a reified call. We can delay when the call is executed. Okay, so before I get to that, so button X is type, because if we look back here, button X is going to be type command. So that means we have like some kind of bind method. Close you down so you got more room. All right, so in here, if we have something like bind jump, then we can have, I guess, the key code to bind the jump button, and then we can have this dot jump command equals So it's going to be the key code. Okay, so this is, oh, okay, so it's not jump command. This dot jump button equals key code. So we instantiate the input handler, and then we can call bind jump and pass in the key code. So I guess this would be something like, okay, click on rebind and then click any key on your keyboard. We'll capture the key code of whatever is pressed in. And then that becomes the new jump command. Then, so this dot jump button. Okay, so now if this is no longer button X, this is now this dot jump button. These go away because we're not using other buttons at this point in time. So if this is pressed, this dot jump button, then this dot jump command dot execute is called. Now the jump command, we need, okay, right, because the constructor is taking in the jump command, which then calls jump. Okay, so then they're going to, in the jump command, they take in the actor in execute. So this takes in the actor, and then we just do actor dot jump essentially. Okay, so that gives us a jump command. We're passing that jump command in here, and so now it'll be this dot jump command dot execute, just the same. Okay, so then we can make this one class. Now we can use this one class to make any character in the game hop around. We're just missing a piece between the input handler and the command that takes the command and invokes it on the right object. First, we change input handler so that it returns commands. So instead of like actually executing, it's returning this like button X, which is I think it was this jump button. So if it is pressed, okay, we'll return this dot jump button. Nothing is pressed, so do nothing. Okay, so then we want to explicitly, so if we get to this point, we'll explicitly return null. It can't execute the command immediately since it doesn't know what actor to pass in. Here's where we take advantage of the fact that the command is a reified call. We can delay when the call is executed. So do we even need the jump command here? I don't actually know if this is correct. Let's see. Then we need some code that takes that command and runs it on the actor representing the player. Something like, okay, so a command equals input handler dot handle input. So that gives us the command. So the jump button, if command execute, and then the actor. So we need this jump command. So I guess we do, oh, we need to bind it to a specific key. So I didn't bind this correctly. So it's not, oh, would it not be this? It would, maybe we don't use the constructor for this. Maybe in this binds jump, we take, I don't know if it would be like, maybe bind, okay, so bind jump, we take the jump command, this dot jump button equals jump command. A jump command is an instance of the jump command class, which has the actor in it, so we can call execute on it. So we now return this jump button, which has the jump command. And so using it, so we're gonna instantiate input handler. Then we need to figure out what command we're using. So const command equals, we're going to use the input handler and then call handle input. Okay, and so this dot, so it won't be this dot jump button anymore. We need, because that's the jump command. So we need like the actual key code. So jump button equals jump command. So how do we know what we're going to pass in the key code? So essentially it would be our key code. So let's say it would be like 33 or 32 or whatever the space bar was. Handle input. So then this is the key code here. Okay, so if is pressed, we're going to pass in the key code. I guess like because P5.js is global in like the key code of whatever is pressed. I guess that's okay. So we just need more. We need more logic in is pressed because we need to know: are we pressing the jump command, which means that we need so we have bind jump, the jump button, but we didn't bind like what the jump key is. This is actually just the straight up jump command. I guess we could store in here the key code for that, but I think we're missing that. Because like button X is the literal, like, let's say ASCII code for like the space bar, let's say, or the actual button on the controller. It returns this, which I think I've got that part right. So I need this part. Is pressed. We're taking in essentially the key code. And we're going to return a Boolean, which is key is down, so we need to bind. So bind jump, this jump button equals jump command. I wonder if also I need like the key code for it. So I can say this dot key code equals key code. And then, okay, so is pressed key code. This return key is down key code. That way it'll be true. So if the spacebar is pressed, we got 32 down. We call handle input. Do we need, okay, so if pressed button X, so we need to like store the key codes that we care about. Oh, okay. So I think because this is assuming that it's like a controller. So if I have like this controller here, it's assuming it's a controller, which means that there's only X, Y, A, and B, essentially. I'm thinking more of in terms of a keyboard where there's so many keys, I don't want to like hard code all possible keys in. And I think that's a big difference here because they can hard code, hey, we're going to have button X, we're going to have button Y, A, and B. That's it. But if I want like just to have anything whatsoever, I need to have maybe like a global whatever like button jump is, instead of mapping it to a specific key on the keyboard. I mean, I don't know. Maybe games do that. Maybe games actually do map out the entire keyboard and like figure out what's going to be pressed based upon this. But okay, so if button A is pressed, so we have the key code is being passed down. So hand input, I'll bring in the key code. We potentially don't need to do this because, especially with like P5.js, we just have access to if the key code is passed in. So this dot is pressed. I guess this is where we need, we don't really want to do this then. We need a different way of knowing, okay, what is like jump? So we have the jump button. Then we might need to also like have jump key code equals, oh, what is the command? It is key is down, I think. Oh, that tests what key is down. I need the opposite, like an actual, okay, whatever key is down, just like give that, put that in. So when I bind, so let's just put in, we will take the key code in here. And then we'll store key code here. Okay, so it's similar but not exactly the same. So when we bind the jump command, we're gonna say, okay, this dot jump button equals the jump command that we pass in. I suppose we could then actually not require this when we call the input handler. We can use a constructor for this. So we can do a constructor. So we can have the jump command. So back to this again, we're going to do this dot jump command equals jump command. Then bind jump is just going to take the key code. This is jump button is now going to be this dot jump command. So essentially it's just a reference to that, and then we're swapping out references with jump button, and that's just how JavaScript works. And then our key code is now in jump key code. So now, if this is pressed, this dot jump key code. All right, so hey, if we're pressing down jump key code, which means that we don't really need to use like is pressed, do we? Because there is a P5 thing for us. We can just straight up do key is down. If key is down, this dot jump key code. And that's a Boolean. So, okay, so if that's down, then return the actual jump button. So now, okay, so input handler new, we have to pass in a new jump command. That has the execute on it, but we haven't done anything with it. Let's hold off on that for a second. Then we have our which command is called. Okay, so handle input. We pass in 32, which is the space, but we can't really do that, can we? Because it doesn't care about that anymore. So now we need to bind. So somewhere in like maybe our initializer. So we're gonna have our setup is gonna be in here and in draw, or maybe I'll just call this the game loop happens down here. All right, so in setup, we're gonna have our input, we're gonna initialize our input handler. We pass in the jump command and what other commands we can do. We need to bind the jump. So maybe these are initial binds. So we can say input handler dot bind jump, and this is going to be whatever the space command is. And I believe I actually put that down here. Key code space is 32. So I can just do 32 is the space. That's our default. If at a later time we allow the player to rebind, then we just call bind jump and hand it a different key code. Now in the game loop, we figure out, okay, what command is being called. So we call handle input. If key is down, this dot jump key code, it returns this dot jump button. So we're gonna get jump button or null. And then we can check to see if the command exists and then call it. So if command is not null, then we're gonna call command.execute. Now this execute requires the actor. And so that's where we're passing in here. So pass in the actor. Assuming actor is a reference to the player's character, this correctly drives him based on the user's input. So we're back to the same behavior we had in the first example. But adding a layer of indirection between the command and the actor that performs it has given us a neat little ability. We can let the player control any actor in the game now by changing the actor we execute the commands on. In practice, that's not a common feature, but there's a similar use case that does pop up frequently. So far, we've only considered the player-driven character, but what about all the other actors in the world? Those are driven by the game's AI. We can use the same command pattern as the interface between the AI engine and the actors. The AI code simply emits command objects. This would have been like helpful when I did last year in August. I did the Pong AI using machine learning, and that would have been helpful having this because I had to sort of like create the two inputs, and it sort of was like moving paddles up and down, but this would have been so much nicer. The decoupling here between the AI that selects commands and the actor code that performs them gives us a lot of flexibility. We can use different AI modules for different actors, or we can mix and match AI for different kinds of behavior. Want a more aggressive opponent? Just plug in a more aggressive AI to generate commands for it. In fact, we can even bolt AI onto the player's character, which can be useful for things like demo mode where the game needs to run on autopilot. Am I doing the conference this year? I hope that I am. It kind of depends also if the conference happens this year. Knowing Kyle Coberly is the sort of like the head of the conference. It will be happening. He's very good at like being agile and sort of like changing to different environments. So I'm sure that he's figuring out how to do a remote conference. That being said, he hasn't done a call for talks yet. The decoupling here between the AI that selects commands and the actor code. Wait, no, I did that one. By making the commands that control an actor first-class objects, we've removed the tight coupling of a direct method call. Instead, think of it as a queue or stream of commands. For lots more on what queuing can do for you, see event queue. All right, so we have our AI command stream and then goes to an actor. So basically, we can call this command multiple times. Like we can call input, handle input multiple times. And it doesn't, like, sometimes it's the player that we're checking, and sometimes it's the not player. Why did I feel the need to draw a picture of a stream for you? And why does it look like a tube? Some code, the input handler or AI produces commands and places them in the stream. Other code, the dispatcher or actor itself, consumes commands and invokes them. By sticking that queue in the middle, we've decoupled the producer on one end from the consumer on the other. If we take those commands and make them serializable, we can send the stream of them over the network. We can take the player's input, push it over the network to another machine, and then replay it. That's one important piece of making a networked multiplayer game. Okay, interesting. So that's how we can just say, just like a list of the, essentially the key codes that are being played. And then, so that's what we're doing. We minimized what we have to send over the network. It would be interesting once you learned a couple of these design patterns. It could be a conference talk topic. I was actually thinking about that last night. I'm actually looking forward to potentially doing some meetup or conference talks about some of these. Undo and redo. The final example is the most well-known use of this pattern. If a command object can do things, it's a small step for it to be able to undo them. Undo is used in some strategy games where you can roll back moves that you didn't like. It's de rigueur in tools. I don't think I pronounced that right at all. That people use to create games. The surest way to make your game designers hate you is giving them a level editor that you can't undo their fat-fingered mistakes. I may be speaking from experience here. Without the command pattern, implementing undo is surprisingly hard. With it, it's a piece of cake. Let's say we're making a single-player, turn-based game and we want to let users undo moves so they can focus more on strategy and less on guesswork. We're conveniently already using commands to abstract input handling, so every move the player makes is already encapsulated in them. For example, moving a unit may look like, all right, so more code. So we have a move unit command class, which extends command. So then they have a move unit command Oh no, this is the constructor because it's named the same. So that's sort of like Java in that case. It takes in the unit X and Y. And I guess it's just storing them internally. So that's what the underscores that they're using are. It's just sort of like the internal. It's sort of like this. Virtual. Okay, so then we're going to have the execute command the saved unit, so this dot unit, move to x and y, and so move to is some method that they have made inside of here. So does that mean we need move unit command needs to be instantiated many times, it sounds like. So that's what this is looking like. We're gonna have, so maybe this is the move unit example. So we're gonna have class move unit command. All right, so we have a constructor here that takes in a unit. It takes in x and y. So these are positions here. And then we're just going to say, okay, this dot unit equals unit. This dot x equals x. This dot y equals y. Then in here, we're going to have an execute method. It doesn't take anything in. It's going to okay, so the unit itself has a move to method on it. So essentially it's like the actor, right? We're going to be able to say unit dot, this dot unit dot move to, and then we're going to pass it x and y. And it's trying to say like, okay, private. There's not really private or public in JavaScript. I guess there kind of is, and they're working away on what the exact syntax is. I think it's something like a hash. I'm not super thrilled with that. TypeScript does have that, but we're not using it. So note this is a little different from our previous commands. In the last example, we wanted to abstract the command from the actor that it modified. In this case, we specifically want to bind it to the unit being moved. An instance of this command isn't a general move something operation that you could use in a bunch of contexts. It's a specific concrete move in a game's sequence of turns. This highlights a variation in how the command pattern gets implemented. In some cases, like our first couple of examples, a command is a reusable object that represents a thing that can be done. Our earlier input handler held onto a single... I forgot that this extends command. Where was I? This highlights a variation in how the command pattern gets implemented. In some cases, like our first couple of examples, a command is a reusable object that represents a thing that can be done. That was our jump command. Our earlier input handler held onto a single command object and called its execute method anytime the right button was pressed. Here the commands are more specific. They represent a thing that can be done at a specific point in time. This means that the input handling code will be creating an instance of this every time the player chooses a move. Something like command handle input. Okay. Right, so now we have handle input. We have our unit. So this is essentially like the actor before. We're now calling it unit. So get selected input. I wonder, okay, so unit equal, that must be a like a global function that is just available to us. Get selected input. If is pressed, button up. So then it's the same exact thing. If is pressed, button up, then figure out what y is. dest y. Return new unit. Okay, so return new move unit command, the unit X position, and the destination Y. Oh, okay. So that's like select the command and then press like the up button on your keyboard. And that's what's happening there. And then down button is the same thing except moving it down. And that's very similar to what we have here, except instead of returning, like, instead of memorizing the key codes and then returning those, we're generating a brand new one every single time with this new move unit command. Of course, in a non-garbage collected language like C++, this means the code executing commands will also be responsible for freeing their memory. When we eventually move back to Rust, because hopefully I'll have my computer soon that can handle that, then we won't need to worry about this either because Rust handles the memory for us as well, which is really awesome. The fact that commands are one use only will come to our advantage in a second. To make commands undoable, we define another operation each command class needs to implement. Okay, so class command. So this would be adding undo. So let's maybe like implement this. So we have their move unit command. So handle input. If I change this to like handle move input, so that way we like see that they're different here. The first thing we need to do is get the unit. And it looks like this unit is not used anywhere else. So we can just say, okay, const unit equals, and then this is gonna be some global get selected unit function. Then it's gonna be exactly the same thing that we have here. So if key is down, and then it's going to be this dot essentially move up. So maybe we can bind up key code, and we'll say this dot up, move up. Key code equals key code. And then, okay, so this dot move up key code. Okay, so if this is true, we return a new move unit command. And then we pass in what we need here, so the unit. And then we need to figure out, I guess, like the X and the Y. And so it's not quite as easy as just doing this in one line like we did here. So we need to figure out what the Y destination is. And so I guess this is just moving one pixel up. So we can do that. So we can have const, essentially it's gonna be like the new Y, or I guess like destination Y, equals our unit dot like essentially location dot Y minus 1. But then now we can return new move unit command, pass it the unit, pass it unit dot location dot X, and then destination Y. It'll be used in a very similar way down here. And then, of course, we have our return null at the end. this allows us to have an undo command in here. But it is reaching 8:14. I do have stand up in a few minutes, and it looks like we have more code than we can handle right now. So I'm going to make a note. We are at this point, so I'm actually going to go into the README. Left off at here. So I'll save that. I'm also going to put this up. I'm going to save u commands. Put you on up into GitHub. So, so this is a work in progress. We are learning the command. I guess like the command pattern. And I'm going to push up this branch. And did I ever sign in to GitHub on this browser? I keep on forgetting to. No, I did not. I'll leave that up, so I'll try to remember next time. Until then, let's go to this browser. So here's my learning game design patterns. So I now have a branch, chapter 2 command, and that's where we've added in these other, like all the code that we have is in Playground. And then once we finish this chapter, I'm going to go into the game and refactor it based upon what we've learned.